Oh, hey, Mr. Who.
Oh, whoa. How's it going, Caroline?
Hey, good.
That's good. Wow. Wow. Whoa. I'm so excited.
What are we doing today?
What a good question. You will see. Um, I was um I was saying that I should just have you, Kate, and you two and Kate just color code and make all my assignments look really pretty because all my
Yes,
assignments
We will totally do
I will
that.
totally do that for credit.
well I mean I don't know
Can we
about
get like extra credit for it, maybe?
um I don't know about extra credit. You just be doing me a favor. Um, well, let me put it this way. You'll I'll appreciate it, and that's yeah.
Eh.
Yeah, see, that's the thing. That's the thing. Nobody wants to. Yeah, I know. I know. I understand. I don't. No, that's fine. I'm just saying. I love how quickly you noped out of it. Um, see, but I would, if I said, like people, if I said, if you have to come to office hours every day for extra credit, I guarantee you, like you would be there every single day for extra credit. It's just, it's just like, I think it's too,
For
I think
sure. Would totally do that.
what'd you say?
I would totally do that.
I know exactly. It's too, I don't know. It's, but no, I'm glad I know where I stand in terms of, yeah, I know how much I mean. Okay, so what we are going to do is we are going to start with our warm up of the day, and then we will go talk about why. Oh, we'll talk about a lot of things. Okay, so to get started with in this particular problem. Oh no, it's not showing. That's an issue. Here we go. Okay, so to get started, once upon a time, this was probably when I was like 2 years old. Um, I was like very well. I mean, I won't say I've changed. I was like very like rambunctious. As soon as I learned how to walk, apparently I thought it was really fun. So I would just like run around all the time, and I would like make people chase me. And I also had no chill, and I had no sympathy for anybody. So I made my grandpa chase me around on a plane. True story. I was a very vicious person. And also one time my mom was chasing me down some stairs, and she was wearing high heels, and I think she broke her leg because of that. So the lesson of the story is some people change and some people don't. So for this particular problem, we're looking at the plane here. In this particular problem, we're using the cockpit as a reference point. I started 2 meters away from the cockpit, and I'm running at 5 meters per second away from the cockpit towards the back of the plane. And I want you to figure out which of the following equations best describes my motion. We have 4 answer choices for you to pick from. X is equal to 10 plus 5 times t. 5 is equal to 2 plus v times t. 2 is equal to x plus 5 times t. And then x is equal to 2 plus 5 times t. So we have a few different choices for you so far. The amount of participation we get today is the grade that everyone gets for the semester. So if we get a 15% participation, that is a 15% grade for everyone in the semester, because that's exactly how grading works. So our goal here is, we do want our goal. Let's shoot for a. Ooh, what are we feeling today? So today, I feel like today has been a little lackluster in terms of hitting my goals. So we're gonna set the goal real low today. We're gonna say our goal is 70% responses. So so that's 14 people. We're at 7 right now, so I'm feeling pretty good. Let's hit 14 people today. I think we can do that. And then that will be everyone's grade for the semester because that's exactly how it works. Okay, so let's figure out what best equation best describes my motion. I'm starting 2 meters away from the cockpit, and I'm running at 5 meters per second away from the cockpit towards the back of the plane. Which of the following equations best describes my motion? Let's take another 2 minutes or so, 1 more minute or so for us to figure this out, and then I will do it on the board. Okay, I'll take another 30 seconds or so. Okay. So to start off, I'm going to draw a plane. So at the cockpit, this is our reference point. So at this point, our position is 0. I'm starting here. My position is x equals 2. And I'm running at 5 meters per second away from the cockpit. So in order to describe my motion, what I want to do is I want to say, okay, I want to be able to tell you where exactly I am at any given point in time. So how do I tell you where I am? Well, I think it probably first helps to tell you, I want to tell you where my x is, where my position is. I think it'll first be helpful to tell you where I'm starting, my initial position. Let's call this x sub 0. Plus how much I've moved after a certain amount of time. So how much do I know? How much did I move during the time? Well, if I'm traveling at some velocity, how much I moved is just my velocity times my time. That will give us how much we moved. So my position at any given point in time is my initial position plus my velocity times time. So if what I can do here is I can plug in the information we know to try to show you what my position is at any given point in time. So what is my initial position? Well, my initial position in this problem is 2 meters because I'm starting 2 meters away from the plane. What is my velocity? Well, my velocity is 5 meters per second. So my velocity is 5. And so my equation for my motion is just x is equal to 2 plus 5 times t. So that's just the general gist of it. We will do a lot more of it today, and you will get a chance to practice your equation skills. So here's what we're doing today. On Canvas, there is an assignment called Wherefore Art Thou, which is just like a very Shakespearean and very like pointless way of just saying, where are you? But the goal of this is to show you how more words is definitely better than using less words because it just makes things so much better. So I'm going to put a link right now in the chat. That's what we're going to be working on today. I'm hoping that we will be able to finish a good portion of it, if not all of it today. I think a lot of groups are able to finish all of it, but that's sort of the goal today. I want you to finish this first before you go back and revise or finish Codenames Velocity Part 2, if you have not finished revising it yet. Codenames, in terms of due dates, Codenames Velocity Part 2, that will be due, I said Sunday, Monday, but I forgot that Monday is MLK Day, so it'll be due Monday, Tuesday. So Tuesday for us. And then this assignment will be due Thursday, Friday. So you'll have a week or so to finish it, but you should be able to finish most of it, if not all of it today. Okay. So on the assignment, there should be a warm-up problem for you to start off with, just to get your brains going. Oh, I should introduce the assignment first. Sorry, gotta do that. Okay, so In the assignment itself, the point basically, if you have any sort of parents, guardians, family, people, basically people who are very interested in knowing exactly where you are at any given point in time, you probably have some experience where like, where are you? Question mark, question mark, question mark. Come home, question mark, question mark, question mark. You're in big trouble, question mark, exclamation mark, right? So they always want to know exactly where you are. However, you don't want to do that because that's so lame. It takes so much work to do that. And you don't want to text them every time you go to the bathroom or you go to the gym or you go hang out with your friends or go to the park or go to class or whatever. You don't have to text them every single time. Instead, as a physics student, you decide to be really clever and you decide to give them an equation so that way they know exactly where you are at any given point in time. Right? So you give them an equation and they can just plug in a time and they will know exactly where you are. So you know that your position x at any given time t is your initial position where you're starting plus how much time, how much distance you've moved during that time frame. So in other words, your position equation is just your initial position plus your velocity multiplied by time. So you can just express your position using the following equation. X is equal to x sub 0 plus v times t. X sub 0, x naught, it's not x times 0, it's just like a little subscript. It's just like, you can just treat it as another variable. That's the variable that means your starting position. V is your velocity, t is your time, and x is your position at that specific point in time. One thing you should consider is that you won't have every single variable given to you. So if you have any unknowns, you should leave the unknowns as their respective variables. Your goal is to try to write equations for the following scenarios and solve the problems posed by your parents, guardians, family, brothers, siblings, whatever. The reference point for each problem is your home. I want you to be careful with directions because you'll need to use directions for these. I want you to treat north, south, east, west as x, y directions, and remember to use negatives and positives, as well as include compass directions when relevant. Make sure all of your answers have the proper units. So you want to be working with directions. You're going to treat the north south as your y direction, as like a y direction. You can treat like east west as an x direction, which means that east is positive, north is positive, west and south are negative. So that's going to be very important when you go through this assignment. The reason why all your stuff should have units and why you should have directions for things is that your parents want to know exactly where you are. If you say, hey, I'm 100 away, they don't know if you're 100 feet away, 100 inches away, 100 meters away, 100 miles away, right? Those could all be issues, right? They want to know exactly where you are. Otherwise, they're going to be very upset and then they're going to send you to a room on a timeout. Additionally, not only do you need units in order to tell them how far you are, they also want to know the direction, right? Because if you could be 100 north, 100 south, 100 east, they want to know a direction. So you need to give them a direction and you need to give them a unit as well as a distance. So that's the only way in order to successfully tell someone where exactly you are. And you can also express directions in terms of negatives and positives. So those are all going to be very important as we're going through this today. Last but not least, each question in this is completely unrelated to the previous one. This is very important because it's going to be very easy to use numbers from previous stuff, and I don't want you to do that. So each problem is independent of any other problem in the assignment. Yeah. Okay, so for now, I just want you to quickly do the warm-up problem on the assignment. Supergirl flies through the air at 500 meters per second for 5 seconds. How far does she fly? Just a very, very quick problem just to get your brain going, and then we will show you how to do the first. Okay, so hopefully you were able to quickly go through the first problem. It should just be 500 times 5, which is just 2,500 meters. Um, just a quick problem. What I'm going to do now is I'm going to first go over the first example problem on the assignment. So you can just fill this in as I talk about it. So in this particular problem, I start at home and then I walk 10 meters per second east. Start at home and I walk 10 meters per second east. So the first thing I want to know is where's my starting position? Well, I'm starting at home and we're using home as a reference point, which means that my initial position is just 0. Right? If I said I started somewhere else, this would not be 0. But since I started at home, my initial position is just 0. What is my velocity? My velocity in this particular problem is 10 meters per second east. You can also just write this as positive 10 meters per second. This way is probably easier. The reason why I use positive is because positive is east, negative is west, right and left. What is our position equation? So what we're going to do is we are going to use our velocity in our initial position, and we're going to plug this into this equation. So my x position at any given point in time is my initial position, which is 0, plus my velocity, which is 10 times 20. 10. In general, if a position equation, you generally want to have your x as an unknown, and you have t as an unknown. You have a general equation that you want to use. You generally want, yeah, so then you can plug in one thing and get another one. So the next thing we're gonna do is we want to figure out how far we traveled after 10 seconds of walking. So what I'm going to do is I'm going to plug in 10 seconds into time. So my x position, my distance traveled, is equal to my velocity times 10, so 10 times 10, which is just 100 meters east. Something similar for the next problem. This time I know my distance, but I don't know my time. I actually want to figure out my time. So I know that my distance traveled is 500. So I'm going to plug in 500 for x, and this is equal to 10 times t. So 500 is equal to 10 times t. I divide both sides by 10. So 500 is equal to 10 times t. Divide both sides by 10. So I get that t is equal to 50 seconds. Bam, that's it. So that's how you quickly do a problem like this. I think if you can build a position equation like this for any particular problem, you are pretty much good to go. So this is your goal here, to be able to write an equation for any particular problem. And that will be our goal for today. So what we're going to do right now is I want you to first work through the practice problem. We'll take about 4 or 5 minutes or so. I just want you to work through the practice problem, and then I will go over the practice problem on the board just so everyone has a good sense of how to do it. And then I will let you work on the rest of this assignment for the rest of the period. Um, is the second problem going, is the person going further away from home or closer? You mean it for the practice problem? It might help to visualize it. If you're starting west of your home, and then you're moving away and you're moving west, right? Are you moving away or closer? So that's something you should think about. The directions, think about it in terms of directions. If you're starting in this direction and you're going in that direction, how far away are you going? I'll take another 1 or 2 more minutes or so, and then I will start going over this. About 30 seconds or so. Ooh, good question. Velocity can't be negative question mark. I don't know. We'll see. We'll see. So, okay, so first off, let's talk about where our starting position is. Okay, so we're starting 200 meters from home. So position is 200. Oh, wait, I forgot something. We're starting 200 meters west from home. We're not starting 200 meters east, we're starting 200 meters west. Oh, west, left, negative, right, east, positive, which means that our starting position is not 200, it's actually negative 200. No way. Yahweh. Yahweh. It can't be. It just. Yep. Pretty wild. So now we started. So we started negative 200 because we're starting 200 west, and then after 10 seconds we ran another 100 meters west. So that means my final position is 300. Negative 300. How much time does this occur over? This occurred over 10 seconds. Okay, so the next question asks you to find your position equation. I actually think it's probably better to find your velocity first. So in order to find our velocity, we can use our general equation. We can just plug information we know in. So x is equal to x sub naught plus e times t. I can plug in my final position, which is negative 300. And this is equal to my initial position, which is negative 200 plus my velocity times time, which is 10 seconds. So I just plug all the stuff I know into the general equation here. And then I will get that my velocity is negative. Or is it negative? Ooh, interesting. Interesting. Does this make sense? Well, in this particular problem, we are going west. We're running west. West is negative. So our velocity tells us both how fast we're moving and in which direction. So which means that our velocity should be can and should be negative. So this is true. Speed cannot be negative, but velocity can. So in this case, our velocity is negative 10 meters per second. We can now use this our initial position to write a general position equation for this problem. So if I want to know my position x at any given time t, I know that it's my initial position, which is negative 200 plus my velocity times time, so minus 10 times t. So from this general equation, I can now know where I am at any specific time, or how much time has occurred at any specific position. So that's the gist of it. Let's just do one quick problem again. How long did it take to hit 550 meters west? Well, I'm gonna now use the general equation we have now. So at 550 west, we are at negative 550. This is equal to negative 200 minus 10 times t. So if we do this, we get that t is equal to 30. Okay, so hopefully this should be helpful for you as we get through this assignment today. If you have any questions, you can always let me know. Otherwise, I will let you get started and you can let me know if you have any questions or any comments or any complaints. It's also okay. All right, we got a minute left, so hopefully you were able to make some good progress. If not, get completely get close to finishing it. Okay, so in terms of homework, finish the Codenames Velocity Part 2, the one we did on Tuesday. Finish it by next class, which is next Wednesday. So finish it before then. Finish this before next class, so next Friday. So that's your only assignments for this weekend. Hopefully it doesn't take too long. Let me know if you're struggling with it. I have office hours again, usual 2:40 to 3:40 if you want to come by and say hi. Other than that, I will see you all next Wednesday. Have a nice 3-day weekend. Go have fun and be crazy or whatever. Yeah. Farewell.
Thank you.
you.
Mr. Hu.
Thank
Bye-bye.
Have a
Bye-bye.
good weekend.
Farewell.
Thank you.
Thank you.
Farewell. Bye-bye. See you, Gabby.